Welcome students. Let us continue our discussion on the topic impulse momentum by solving some more examples. Just a quick revision. Impulsive force is a force which has a high magnitude which acts for very small amount of time and causes the change in momentum. So this is nothing but the impulsive force, and we already know that momentum is the product of mass and velocity. We have seen the relation that for impulse momentum equation, impulse, that is F multiplied by T, is equal to change in momentum, that is mv minus mu. So this we have already seen in the previous lecture, and we have also solved one problem. Let us continue by solving some more examples on this particular type. The next question is, a tennis player strikes a ball with a racket while the ball is still rising. The ball has a speed of 10 meter per second before impact and 17 meter per second after impact as shown in the figure. If the 75-gram ball is in contact with the racket for 50 milliseconds, determine the impulsive force. So starting with the solution, the first step will be to resolve the velocities. This incoming velocity, the value is given to us as the ball has a speed of 10 meter per second before impact. So initial velocity is 10 meters per second, whereas it is 17 meter per second after impact. That means the final velocity, or v2, is given to us as 17 meter per second. Now both these velocities are inclined at some angles, hence this should be resolved into x and y components. So for resolving, this particular velocity will be resolved in x direction and y direction as 10 cos 10 and 10 sin 10 respectively. Similarly, this velocity v2 will be resolved into two components x and y as 17 cos 20 and 17 sin 20 respectively. Now let us go for applying impulse momentum equation. So starting with the impulse momentum equation in x direction. So first I will write what is the impulse momentum equation. It is mu plus impulse is equal to mv. Now in place of impulse I can write summation of f into t, but here as I am applying impulse momentum in x direction, I will assume the initial velocity in x direction, force in x direction, and final velocity in x direction. Now let us substitute the values. M is given to us in the question as 75 grams, so it will be 75 divided by 1000 multiplied by ux, that means initial velocity in x direction. So if you observe from the figure, the initial velocity, that is v1, in x direction is 10 cos 10. So it will be minus 10 cos 10. Now why negative? Because it is going towards left side. Plus fx, so I will write fx as it is because I don't know the force acting on it, multiplied by t. The in question it is given to us as it is in contact with the racket for 50 milliseconds. So I will write down here 50 divided by 1000, converting into seconds, is equal to mass. Again I will write 75 divided by 1000 multiplied by vx. V means the final velocity in x direction. So if you observe in the figure, the final velocity, that is v2, in x direction is 17 cos 20. So I will write here 17 cos 20. The same thing I have written here, 75 divided by 1000 multiplied by minus 10 cos 10 plus fx into 50 divided by 1000 is equal to 75 divided by 1000 into 17 cos 20. Now in this entire equation, the only unknown is fx. So on solving it, I will get the answer for fx as 38.73 newtons. Now as we applied the impulse momentum equation in x direction, now let us apply impulse momentum equation in y direction. So starting with the impulse momentum equation, I will write mu plus impulse is equal to mv. In place of impulse, I can substitute summation of f into t. But here, as I am applying impulse momentum in y direction, the velocities will be considered as u, y and vy, and also the force will be fy. Now substituting all the values I will get, in place of m I will get 75 by 1000 multiplied by uy, that is initial velocity in y direction. So if you observe from here, it is 10 sine 10. So I will written here 10 sine 10 plus fy will be as it is multiplied by time was given to us as 50 milliseconds is equal to mass is given to us as 75 grams multiplied by the final velocity in y direction. So here you can see that final velocity in y direction is 17 sine 20. So I have written here 17 sine 20. Now the only unknown in this entire equation is f of y. So on solving it, I will get the answer for f of y is equal to 6.166 newtons. Now let us say in equation 1 I got the answer for fx, in equation 2 I got the answer for fy. What was asked in the question? It was asked to determine the impulsive force. It was not asked in the question to determine impulsive force in x direction or impulsive force in y direction. It is just find the impulsive force. That means we have to find what is the resultant impulsive force acting on this body. So I can write from the concept of resultant, I will write F is equal to, that is resultant force is equal to summation of Fx square plus summation of Fy square. So we have the value of Fx, we have the value of Fy. On substituting which I will get the answer for F as 39.2 Newton. So the mistake here is it should be a square here and it is a square here also. Now this completes the magnitude of the force. Now as it is a force, it is a vector quantity, it means it has magnitude as well as direction. So for direction we have theta is equal to tan inverse Fy by Fx. Again substituting the values, I will get the answer for theta as 8.97 degrees, and this completes the solution. Thank you.